Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, a truck traveling at x kilometers per hour, where x is between 30 and 120, uses gasoline at the rate of R at x liter per 100 kilometer, where R at x is equal to 1 over 4 parentheses 4900 over x plus x. If fuel costs $1.15 per liter, what speed will result in the lowest fuel cost for a trip of 200 km? And we have to find the lowest total cost for the trip. So in this problem, we are given this function Rx, which represents the rate at which the gasoline is consumed, and it is R at x liter per 100 kilometer. Now we have to first calculate the total amount of gasoline required for this 200 kilometer trip. So our first step is the volume of gasoline required equals, so it will be R at x, whose unit is liter per 100 kilometer, times 200 kilometers. So that's the total distance for the trip. So now we can simplify this expression, so we can cancel out the kilometers unit, and then we can reduce 100 and 200. So we get, so volume equals, so it becomes 2 times R at x liters, and we can sub in the R at x function, so it's 2 and then times 1 over 4, then times 4900 over x plus x liters. So this is the total volume of gasoline required for the 200 kilometer trip. Now we have to find the lowest fuel cost. So first we'll have to come up with an expression for the fuel cost. So let's assume the fuel cost function is C at x. So for that, we'll multiply the volume by this price per liter. So we'll simplify this expression. So 2 times 1 over 4 is just 1 over 2 times 4900 over x plus x. This is in liters times $1.15 per liter. Now we can cancel out the liter units. So we get C at x equals, so now we can multiply half by 1.15. So half times 1.15 is equal to 0.575. Then 4900 over x plus x. So this is the total cost in dollars for the gasoline required for the 200 kilometer trip. Now we have to find what speed will result in the lowest fuel cost. So we have to find the minimum fuel cost. Now for minimum cost, we'll have to find the x value at which the tangent to the cost function is horizontal, because the tangent is horizontal at the valleys in the graph of the function. So for that, we'll find the derivative of this cost function. Now to find the derivative of the cost function, we should simplify this expression. So the x that's in the denominator, we can move it to the numerator, and that will make it easy to find the derivative. So c at x equals 0.575 times, so 4900, and then x exponent -1 plus x. Now we can find the derivative. So prime of x equals, so 0.575 is the coefficient, so it will stay as it is. Now the first term in the parentheses is 4900 x exponent -1. Now 4900 is the coefficient, so it will stay as it is. And for x exponent -1, we can use the power rule to find the derivative. So the derivative will be, so we move the exponent to the front and subtract 1 from the exponent. And then plus, now the derivative of x will be equal to 1. Now we have to simplify this expression. Now since the x value that we are looking for is for points where the tangent is horizontal, so we can sub in the prime of c at x as equal to 0, because that is where the tangent will be horizontal. So we get 0.575 parentheses, so -4900, and then we get x exponent -2 plus 1. Now we can move the x term to the denominator. So we get -4900 over x squared plus 1. And now we can solve for x by first getting rid of the 0.575. So we can divide both sides by 0.575. So 0.575 on the right side will cancel each other out, and on the left side we'll get a 0 equals -4900 over x squared plus 1. Now we can move this 4900 over x squared to the left side of the equation, and we'll get 4900 over x squared equals 1. And now we can cross multiply the x squared. So we get 4900 equals x squared. And now we can apply square root to both sides. So the square on the x and the square root cancel each other out. And the square root of 4900, so will be equal to plus minus 70 equals x. Now the given interval for x is from 30 to 120. So the -70 is an invalid answer for x. So the final answer for x should be just 70. So this is the x value at which the tangent is horizontal. So that means there are 3 x values we have to consider for our analysis. So the first x value is the lower limit of the interval. So x equals 30. So we should calculate the cost of gasoline for x equals 30, and for that we'll use the expression that we got for the function c at x. So c at 30 equals, so 0.575 times 4900 over 30 plus 30. Now we have to simplify this expression. So first we can simplify the terms in the parentheses. So 4900 divided by 30 and then plus 30 and times 0.575. So I got 111.17, and this is the cost, so the unit for this number is dollars. Now the next x value we should analyze is x equals 70. So we'll sub in x is 70 in this cost function. So C at 70 equals 0.575 and then 4900 over 70 plus 7. Now we can evaluate this expression. So C at 70 is equal to, so first we can simplify the terms in the parentheses. So 4900 divided by 70 and then plus 70 and then times 0.575, which is equal to $80.5. Now the next value, x value at which we have to calculate the cost is 120, the upper bound for the given interval. So C at 120 equals 0.575 and then times 4900 over 120 plus 120. Now we can evaluate this expression. So C at 120 equals, so first we can evaluate the terms in the parentheses. And times 0.575, so I got 92.48. So these are the three costs we have to compare. So the first one is at x equals 30, so C at 30, and then C at 70, and then C at 120. Now the first question is, what speed will result in the lowest fuel cost for a trip of 200 kilometers? And that is 70. So this results in the minimum value. So we can write our answer for this. So you can say, so the speed of, so 70 kilometers per hour results in the lowest fuel cost. So this is the answer to the first part. Now the second part is, what is the lowest total cost for the trip? And the lowest total cost is lowest total cost is, so $80.50, because that's the value of CRX function we got. So this should be the final answer for the second question in the problem. So these are the steps you have to keep in mind to solve a problem like this one. So in this case, we have to use the given function r at x to calculate the total cost for the trip, and then we use that expression for the total cost to find the derivative, and then get the x values at which the tangent is horizontal, and then we use that value to compare the values of the cost of trips to find the lowest cost for this trip. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.